this is where we'll start doing the edited version and deliver a train the trainer update refresher, which we hope will take give or take a half an hour or 40 minutes, depending on how long I talk. The purpose of the Train the Trainer series that we created in 2020 was to review the critical concepts from each module and share recent FDA updates, PSA resources, tips for presenting. So this is a very timely thing for us to be going through now. Our intended audience is PSA trainers and lead trainers, but we acknowledge that a lot of people can benefit from having the exposure to this material and understand how to effectively promote the requirements in revised subpart E. It's important to go through these disclaimers just so everyone knows now and in the recording that attending these office hours or watching their recordings does not count as attendance at a PSA Train the Trainer or grower training course. It does not make anyone's certificate eligible for the PSA AFDO certificates. And also just knowing that the PSA grower training slides are copyrighted. They're not to be published electronically without permission of Cornell University, not to be sold in whole or part for profit. So let's get into Module 5. I'm going to try to avoid referring too much to the old modules because this is moving forward, not looking back, but sometimes it's useful to know that things that changed and didn't change. One thing that didn't change is that we still have an introductory section. In that introductory section, slides 3 through 7 describe revised subpart E and revised module 5.1 a little bit. And then slides 8 through 14 talk about some general water quality standards for agricultural water, and they zero in on that definition of agricultural water. We really want to make it crystal clear what the definition of agricultural water is in the produce safety rule. So we always talk about part 1 being production water, define production water, part 2 being post-harvest water, define post-harvest water. This first introductory slide, and in the bottom of the screen here, you can see that this is slide 3 of the revised module 5.1. The main point of the slide is housekeeping. We're trying to clarify the difference between the printed PSA Grower Training Manual version 1.2 and this upcoming version that includes revised module 5.1. We're going to call that revised version 1.2/1.2a of the Grower Training Manual because the manual itself is identical to version 1.2 with the exception of revised module 5.1. This is where we explain also that there's been a shift from production water to the term pre-harvest water. When we created the PSA grower training curriculum starting back when, pre-2016, we used the term production water. In this new set of requirements that were in the revised subpart E, FDA is using the term pre-harvest water, so we're generally adopting the term pre-harvest water as how we refer to what we used to call production water, but we still have to have some shout outs to production water because all of the other modules in version 1.2 still refer to production water. So although it's a little bit confusing to use two different terms, we do need to associate those two words together. In this module, we do tend to use the term pre-harvest water though, and that's why. Now we get to the numbering system. So in the slides from the Module 5, Part 1, provision numbers are used in the provision numbers in Module 5, Part 1 use the provision numbers of 2024. I mentioned a little bit earlier, 112.43 is now agricultural water assessment. Anyone who saw the original numbers in the original 2015 think that 112.43 means treatment. So we're taking great pains to ensure that a participant in a grower training course knows where to find the numbers. So the first thing to point out to them, or just to be clear, is that information about provision numbering is critical, and without the proper numbering, there can be confusion or ambiguity. So make it clear to participants that the numbers in revised module 5.1 refer to the 2024 numbering system. Everywhere else in the grower training manual, including 5.2 or module 5-2, we're referring to the original 2015 numbering system. Another thing is that, especially for trainers, And sometimes for growers, if the trainer is training out of the version 1.2 manual, it's important to know what was in the original manual and what's in the revised handouts. So we did tag the slides that are the same as the original manual with the in this example we show module or version 1.2 of the manual, slide 4. We also need to talk about compliance dates because the revised subpart E resulted in changes to compliance dates that are not reflected in the compliance date chart that's in module 1. So in this case, the pre-harvest agricultural water compliance dates start in April of 2025, and they come in sequentially through 2027. We also went ahead and threw in the compliance dates for harvest and post-harvest water. Although those were already published, and those are the same as the ones that were in Module 1, you'll notice that in Module 1 it says January 22, 23, and 24. The subtle difference or the real difference that's important is that the compliance dates were 22, 23, and 24, but because of a policy of enforcement discretion, enforcement didn't begin until 23, 24, and 25. So that's why what we're in this slide, we're talking about enforcement dates of 23, 24, and 25, which come 1 year after the published compliance dates. This is where you shift to actually discuss the global requirements for production water. I'm sorry, for agricultural water. There are actually 2 global requirements. So keep in mind when you deliver Module 5.2 that this qualitative standard applies to both production water, pre-harvest water, and post-harvest water, but also the agricultural water systems inspection, which is described early on in revised Module 5.1, is relevant to both Module 5.1 and 5.2. So in this case, the global requirement that we all love to say is agricultural water must be safe and of adequate sanitary quality for its intended use. Something that's new is we used to have this as a supplemental slide that many of us used. Now we put it into the actual curriculum. The definitions are so important because if it's not used as agricultural water, the risks are managed by how the water is used, and it's not covered by the Produce Safety Rules Subpart E requirements. So in this slide, you can really point out, you can read the definition, you can do whatever you want to do to point out that agricultural water is intended to contact covered produce or food contact surfaces, and then also discuss what covered produce means. It's the harvestable, not the edible, but the harvestable or harvested part of the crop. To help you get that point across, we adopted some from a previous supplemental slide set, but we also created a few scenarios, resulting in 6 scenarios that applied the definition of ag water to make sure that some of the most important parts of the definition are always addressed in the PSA grower training courses. This one is the softball, it's the introductory one, and it's used to emphasize that the definition of agricultural water has 3 parts: covered produce, covered activities, and contact. We threw in an example of pesticide application on apples to point out the fact that irrigation is not the only pre-harvest use of agricultural water. Depending on the audience, you might also decide to go into timing because dormant applications that occur before blossom is not a use of agricultural water because the harvestable part of the apple crop is not present during the dormant season. This scenario with carrots and drip irrigation makes the point that it doesn't have to be overhead or foliar application to contact the harvestable crop and be agricultural water. The next one is to make the point about excluded produce because potatoes are on the rarely consumed raw list. Even though it's overhead irrigation, it's not agricultural water. I think we're about to get to number 5, which is a new scenario that you may not have seen before. It brings in hydroponics. Hydroponics is really an emerging market and an emerging way of growing produce. We have a lot of hydroponic operations in our classes. So we wanted to talk in this case about head lettuce that's harvested with roots on. And in the notes, you'll see several discussion points that you can go into depending on the makeup of your participant group. The last one is avocado harvest and packing line sanitation. And the point of this scenario is to reiterate that it's contact with covered produce or food contact surfaces. In each one of the scenarios, Notes are available that will help guide you through the key concepts and evaluate the sorts of things that you might want to say as part of the examples. Now we get to the revised Module 5, Part 1. This is an interim slide set. So remember, what we're doing here is to bridge the gap between publication of Subpart E back in May of 2024 and development version 2.0, which is going to take some time and resources. We want to assure you that we did our best, but in order to get the revised Module 5.1 done with a short turnaround time so that there's not there's not a long gap without appropriate training materials, we were unable to go through the full process with focus groups and other feedback that other modules went through. This has been through FDA review, but it didn't go through the same extensive review that the PSA Grower Training Manual went through as it was developed back when Produce Safety Rule first came out. To be clear, the effective date for these requirements is in July 2024, and the first compliance dates arrive in 2025. That's short time period, so that's another reason why we wanted to do this on an accelerated schedule. This is a supplemental slide that I threw in simply to help you understand the structure of the module. We're up to slide 17 now, or I'm sorry, we will be in a couple of slides. And if you skip forward a little bit, we're going to talk about good agricultural practices and scientific principles first. So all these slides that are in the light green are similar to what you may have seen in previous versions of Module 5.1, and they cover the concepts. Then we have a short transition of 3 slides that talk about the agricultural water systems inspection and the agricultural water assessment and the interplay between those two. Then we have a long period of new slides. These are the light blue slides that discuss the agricultural water assessment elements, outcomes, and measures in response. That ends with some exemptions that are possible from the egg water assessment. And then in purple, we don't want to leave behind any of the information about testing, because testing, although it's not a requirement for pre-harvest water in most cases, it's still a requirement for 5.2 post-harvest water. And because these slides don't appear in Module 5.2, we do really have to have them in Module 5.1 so that a packer who attends the course still gets the information about testing. And testing is always going to be a useful tool and useful input to understanding water quality. And then we'll end with the conclusion slides, as we often do. So back to the revised Module 5.1, we're on slide 16. This is an introductory slide that just talks about pre-harvest agricultural water requirements. This QR code and this URL take you to the FDA's website so that growers and other participants in the course can get to the actual language and the fact sheets that FDA revised. Remember that the revisions changed provision numbers, and some of the wording on sprout and post-harvest requirements are different, but the main effects were just on pre-harvest water requirements. Testing not being a requirement, the MWQP system, the microbial water quality profile system, can still be useful, but the grower also has the opportunity to choose paths that do not require testing. We'll talk about that more for those who've already been through training on the earlier versions of 5.1. This is a key change to make clear. In order to help participants access the codified language again and have access to what does 11243 say now, they can go to the website and the QR code. The last point on the slide is something to emphasize in each grower training course. There are a lot of, we'll call them uncertainties about how this is going to play out. The rule's only been out for a month. We're all trying to understand it. We can do our best, but we may not have all the answers. One key thing to encourage growers to do is to write down, to think through what decision points they made, know why they made those decisions, and be prepared to explain those decisions during an inspectional visit or during questions from someone else. We get to the learning objectives. These are unchanged. The concepts behind managing water quality have not really changed. It's the implementation that has. So we're going through the system that we go through in all of our modules. We're assessing what are the risks. We're implementing what are the practices like water application method. How do these practices affect the environment, soil quality, and wildlife? We're monitoring. Can we do things like test the water in order to monitor and understand the quality of the water? What are do we need to monitor the elements of the agricultural water assessment to see if something changed and a reassessment is required? Finally, we're taking actions in response that are called, in this case, measures. So what are those measures that can be taken if pre-harvest agricultural water risks are identified? And then the record keeping is always a key part of the delivery of any of our PSA modules. As you can see at the bottom left, these first slides have not changed. These are still from the version 1.2 manual. This one used to be slide 8. Now it's slide 18 because of the introductory material. But this slide is the introduction to revised module 5.1, the part on good agricultural practices and scientific principles. It kind of sets the stage for assessing risk. This is a good place to tie back to previous modules when you deliver, bringing up key concepts like we're focused on fecal oral pathogens. Farms rely on water to grow, harvest, and pack produce, so that water contacts a lot of produce, and that's a way of amplifying risk that we want to manage and control. We don't want those risks to produce safety amplified by using water that's not of appropriate quality. You can bring those topics up as you introduce the topic on this slide number 18. This is the slide where we discuss some of the ways that agricultural water is used pre-harvest. It's not just about irrigation uses. Sometimes we fall into the habit of saying irrigation water, irrigation water. You can walk through and describe why each one of these uses of water is pre-harvest agricultural water and how risk could be introduced into the produce growing area if the water is not of sufficient quality. This is the system that we like to use to discuss the three main elements. We talk always about the risk to produce safety depends on the water quality at the source and in the distribution system. The application method, does it or does it not contact the harvestable portion? We talked about that a lot in the definitions. And then the timing of application. Is it at planting or is it close to harvest? Each one of these, this is an introductory slide, so be sure you don't go into huge depth here because this is just meant to introduce those three concepts. As I walk through how to deliver these, keep in mind that the agricultural water assessment has two more elements that are not listed on this slide. One is crop characteristics, the other one is environmental conditions. So as we discuss how to introduce these concepts, I'll also tie those two elements into it. We start with a focus on water sources, describing in general the risk profiles for each type of water. These three types of waters are especially important because the agricultural water systems inspection and the agricultural water systems part of an agricultural water assessment requires that you understand the nature of the water source. And these three categories of water is one way to describe the nature of the water source. So it's going to come up again in the regulatory part of the module. So it's good to bring it up here. And in the notes, you'll see talking points for why surface water is described as a higher risk, public water supply is described as a lower risk. Then we get into some concepts, starting with public water supplies, that help us talk about potential sources of contamination while the water is under the control of the farm, in ways the farm can protect the system from contamination. Those concepts are really important to the agricultural water systems inspection and the agricultural water system that's part of the ag water assessment. In general, for water from a public water supply, the farm can assume that the source is acceptable because in the US anyway, it's covered by Safe Drinking Water Act, and in other countries, it's covered by other acts that manage drinking water quality. But the farm, although the water that is delivered to the curb may have acceptable water quality, the farm is responsible for maintaining the quality of water in the on-farm distribution system. And so here are some recommendations for public water supplies. Then you go into groundwater sources such as well water. The farm has control of both the well and the water distribution system in this case. So you can go through some practical things to look at, like the parts of the well that are above land surface that affect how effectively well water is protected. Consider doing some research online, take a course, talk to a colleague. If you're unable to describe things like, what's a sanitary seal look like? How do you know if it's in good shape? What about a backflow prevention device? How do I recognize that? How do I talk through with a grower? Is my backflow prevention device actually working and accomplishing the goals? What kind of subsurface geology element can we talk about, like confining layers that are going to affect the vulnerability of this well water to contamination? If you can educate yourself on these topics, you can convey those important concepts to the growers, and those are valuable also in the regulatory part of the module. Slide 24 is an optional slide. We generally use this to describe all the sources of contamination that can affect surface water and really underscore the vulnerability of surface water. Explain why surface water was on the red high risk side of that risk diagram that we showed a couple of slides ago. This can also be a useful slide to talk again about fecal oral pathogens, so the participants can focus their attention on, where's the poop coming from? How does poop get into my water? For purposes of produce safety rule, just as a reminder, we're focused on biological hazards like pathogens, and most of the foodborne pathogens that are linked to fresh produce and other raw agricultural commodities are fecal oral pathogens. So it kind of helps narrow down the list of things to worry about, or prioritize the list of things to worry about, if you can remind people to pay most attention to fecal sources and pathways of fecal contamination. Then you get to what is sometimes a relatively difficult topic of, how do you prevent contamination of surface water sources? We talk about kind of a sanitary survey, assessing nearby land uses, upstream water activities. This is also an opportunity to talk through the water distribution system in the same way that you talk through it with groundwater slides. When you're talking about protecting the water source itself, it can be useful to point out that realistically, protecting a surface water source can be difficult. Sometimes the surface water source isn't really under the farm's control, like if it's a river or a stream that flows from off property onto a farm property. So one concept that might be useful when we get to the regulatory requirements is that although the farm doesn't always have the ability to protect quality of the water, especially upstream from the farm, they do have an obligation, and the agricultural water assessment helps them work through the system of understanding the quality of the water and making appropriate use decisions. Stop here, hesitate, be clear that this is a new topic. We're moving away from sources of the water in the distribution system, and we're talking about the agricultural water use practices, like how do you irrigate. As you go through some of the common irrigation methods, it can be useful to tie concepts related to crop characteristics into this discussion. So where the product grows on the plant can combine with how the water is applied, and together those factors, those elements, affect whether or not the water contacts the harvestable part of the produce. As you go through that, how do you apply the water, lead up to the punchline, which is less contact with water is lower risk. We already talked about that a lot with the definition of agricultural water, and you can use this slide to really nail it and bring that concept home. The last of the practices and scientific concept slides describes the third major category of risk factors. Remember, we already went through the source, the application or use methods, and now we're talking about timing. On the application slide, you were able to bring in another concept that's useful. In the last slide, we talked about crop characteristics. In this slide, you can really talk a lot more about one of the other components of the agricultural water assessment, the environmental conditions. You can introduce this topic by talking about the FAT-TOM concepts from Module 1. We talked about the food, acidity, time, temperature, oxygen, and moisture as being components that allow a bacterial pathogen to grow or speed the die-off of bacterial pathogens. Those types of conditions can also affect the survivorship of viruses and protozoan or other parasitic pathogens. Those conditions that allow most human pathogens to survive or thrive can be related to the environmental conditions that affect survival. You could also talk about crop characteristics like surface roughness and internalization here in the context of pathogen survival. This slide marks the end of the conceptual slides. I should point out the big picture here is more time from application, more time between contact and consumption, generally speaking, is going to lead to more microbial die-off. With that concept, that end of the conceptual slides, you can stop to reinforce those three key categories. You could also take those, there are two optional slides. They're now numbered 54 and 55 that talk about the source, the application method, and the time. And those slides can be used here if you care to, in order to reinforce that these three things feed into your thinking about risk. They're also valuable where we put them at the end of the slides. This is your first big breakpoint. Up till now, the material was non-regulatory. It focused on concepts. Now you could consider reviewing those concepts again, linking the water so that you can link the agricultural water systems inspection with the quality of water sources and strategies that were brought up previously. In this slide, we would recommend talking about it being a requirement for both pre-harvest and post-harvest water. These are the first two bullets are good recommendations, and then the second two bullets are key must statements when you're delivering the slide. Because again, your patter, you've probably gotten into an educational patter, and now we're talking about regulatory concepts. This slide is one of the first ones in the revised module 5.1 that is new. This one introduces the key requirements of an agricultural water assessment. I think it's important to know that the agricultural water assessment is described in 11243A. I don't think I'm going to read it to you. The notes are in module 5, in this slide's notes, but it describes each one of these characteristics that's on the slide. That it must identify conditions, that it must be done at the beginning of the growing season, unless you have year-round growing seasons, but at least once annually, that it must be reassessed when there's a significant change, and then the record keeping written, reviewed, dated, signed in a reasonable time. So that just introduces the concept and lets people know what the key aspects of compliance will be, the things that we can check boxes and know. After you've gone through and talked about the agricultural water systems inspection and agricultural water assessment, you may find that people are confused about what's the difference between them. So this slide is an opportunity. Based on discussions up to now, we know that people are having trouble keeping clear what are the differences between those two things. They're different things. Each one requires a record. The systems inspection covers each ag water systems, both pre-harvest and post-harvest. The assessment only applies to pre-harvest, water used in growing produce that's not a sprout. That said, the results of the agricultural water systems inspection can be, and probably should be, part of the agricultural water assessment for those farms that have to do both. When we think about delivering this module, we start this one by saying, okay, what is the point of an agricultural water assessment? I look in the gray box and I say the agricultural water assessment will identify conditions that might introduce hazards into water. That's the first thing. And then importantly, determine whether measures are reasonably necessary to reduce that risk. So what are the sources of often fecal contamination, and how do I disrupt it? It is a system that requires a lot of thinking. And for that reason, FDA has created the Agricultural Water Assessment Builder tool to help people think through the components that we're going to go through on the rest of this slide. So sometimes it can be helpful to let people know that resources are available to help them through it. We already talked about in the introduction, but let's go through them again. that there were 5 elements in the agricultural water assessment. The egg water system inspection, I'm sorry, the egg water system characteristics, many of which were already written down in the egg water system inspection. Then we also have the agricultural water use practices, crop characteristics, environmental conditions, and other factors. This is an introductory slide. Use this to link with the agricultural water systems inspection and just to introduce the other 4 elements. In the notes of this slide, slide number 33, we reference an FDA fact sheet that's the basis of this table that walks through each one of the 5 elements of an agricultural water assessment. And it talks about some characteristics that make the agricultural water, that system, more susceptible or less susceptible to contamination. So things like that we've already talked about. You can tie this back to those gaps or scientific concept slides that we talked about earlier. The nature of the water source. Surface waters are more susceptible. City water, muni water, drinking water, groundwater, less susceptible. The type of system. If it's an open system like a canal, the distribution system, it's going to be more vulnerable than a properly maintained closed piped system distributing the water throughout the farm. The degree of protection. Are animals and humans in the water, or are they prohibited from being in the water? You can walk through some of the concepts, some of the guardrails, some of the factors that would help a grower evaluate whether they actually do have conditions that could cause contamination to get into the water or be transported into the water. Agricultural water use practices, we talked about these also in those introductory slides. The application method, less contact is lower risk. The time interval, more time is lower risk. Then we talk about crop characteristics and environmental conditions. These are 2 areas that are new to many people's assessments of risk, but they are also concepts that we often tie into the introduction of hazards and the survivorship of hazards. So if a leaf surface has rough texture, if it's waxy, if it's fragile and vulnerable to damage, these are all things that can increase the risk compared to the opposite. Waxy being something that reduces the risk, and a rough texture or something that's going to allow the pathogens to stick being something that increases the risk. So effective use of these 2 elements to make decisions is going to require the ability to integrate information into the holistic systems approach. It's a good idea for all of us as trainers, to be up to date on research and principles that help participants do that integration. In the preamble, FDA mentioned several times that these requirements leave a lot of room for scientific advances. In other words, we may not have the answers today. So the answers to a lot of these questions have not been developed yet. We may all have to work together with growers, educators, and regulators to develop them over time. Don't be afraid to say, I don't know. And also recognize that if we don't have a firm answer we can give people, one of the mantras I think is going to come into play in this module is know what you did, why you did it, and be able to discuss it in a reasonable way during the inspectional visit if you have one. Finally, under other characteristics, test results are the one other characteristic that comes up in the preamble when we talk about other characteristics. This is the first time in revised Module 5.1 that we bring up the topic of testing. So remember from when we talked through the structure that a lot of information about how to do testing comes up later in the module. Here we're going to focus on why should you do the testing. When we are on slide 36, just talk about why. We'll talk about how later, and you can reassure people that we will be talking about how later. Even though test results don't serve as a sole basis for water use decisions, they can give useful insights to water quality. So in particular, if the assessment doesn't indicate conditions that could lead to contamination, but your test results say there's poop in the water, you probably missed something in the assessment. You can share that kind of information with the participants in your course. If the assessment shows that some conditions could lead to contamination, but you're not sure how vulnerable your system is to those conditions, low test results can be a source of reassurance and a source for making a decision that maybe your conditions are being managed. One of the tricky things to navigate, especially for people who are familiar with the MWQP system, is that in the preamble's comments that are in the notes, the MWQP, the Microbial Water Quality Profile System, could be used as an input to the agricultural water assessment under those specific conditions that we talked about, which we're going to talk about again in the next slide. It's important not to focus exclusively or strongly on the MWQP for two reasons. One is it's not described in revised module 5.1, so you're only going to be talking to the ones in the classroom who already know about the system. And second, it's not the only system of water testing that can be used. Let's get to this chart. This table is based on an FDA fact sheet. We made a few changes that we feel like will make it a little bit easier for some people to understand. On this chart, what we want you to do is go through the determinations, which is the colored boxes, and use those to talk about the outcomes, which are the open boxes. And some people will say you don't consume an elephant in one bite. We're going to try to consume this elephant of agricultural water assessment outcomes and determinations one piece at a time. In this slide, we're focusing on the determinations, the categories of determinations, and the categories of measures. You can reinforce the timing of the measures. If ag water is not safe or of adequate sanitary quality for its intended use, immediately discontinue use and take some corrective actions before you use that water, and so on down through this chart. Remembering that this is the one place testing water comes up in a regulatory setting, remembering that corrective measures and mitigation measures are two terms that are going to be important to know, but don't get into it in too much depth because in the very next slide, we're going to talk about corrective measures and mitigation measures. Notice that the two corrective measures that appear in the list are also in the list of mitigation measures. So we're going to talk about them together in the following slides. Reinspection followed by repairs and treating according to the FSMA produce safety rule. Those can be used in either one of these categories of outcomes. We'll just talk about them once as we go through the materials though. Linking back to that previous slide, if water is not safe and of adequate sanitary quality for its intended pre-harvest use, then only these two corrective measures can be used. Those of you who hearken back to the old system, notice microbial die-off is not one of the corrective measures. Be sure to mention that changing the water and taking alternative mitigation measures are other mitigation measures that are on this slide. Where are they? Here's one of them, taking alternative mitigation measures, and the other one is changing the water application method. Those only appear on this slide. If you change the water application method enough, you're not using it within the definition of agricultural water. So that's one reason to bring that one up. And then taking alternative mitigation measures is another option. Going through our measures, reinspection can be either a corrective or a mitigation measure, keeping in mind the state and local requirements. Treating agricultural water is a topic that's going to be brought up in more depth in Module 5.2. In the short term, it can be challenging to find a chemical treatment method that's labeled for use treating irrigation water to control public health microorganisms. So a chemical treatment that's labeled for the use will have an efficacy statement, something like if it's used as directed, it will reduce 99.9% of target organisms like E. coli 0157 and Salmonella. Since most of the information about EPA labels is presented in Module 5.2, focus your delivery on what the EPA labeled, focus your delivery on the material in the slides, and know that 5.2 is going to talk about those labels. Die-off and removal can be a little complicated. Remember, it's only a mitigation measure, not a corrective measure, and it's going to be able to be used in both a qualitative or a quantitative. What I mean by that is, if in some instances, a grower would be able to assume 0.5 logs per day die-off of pathogenic microorganisms in the field. In order to use that information, you would have to have both a starting concentration and a target concentration so that you could calculate 0.5 logs per day, how many days do I need? Instead of a quantitative way of doing it, because if you don't have all that information, you could use it qualitatively. I think that 5 days is long enough to reduce the risk that I observed in my agricultural water assessment. We currently don't have much guidance on how to effectively apply and explain why a particular number of days is considered long enough. So that's another area where there is room for future scientific data to better explain that system. Reassessments are going to be done each year, and anytime there's a significant change in the system, so you want to talk through that reassessment. Um, the agricultural water assessment is not necessarily a one and done. There is going to be a requirement or a need to continually um, reevaluate those elements to see whether something changed significantly and whether a reassessment is necessary. Thank you, Michelle Danilick. I just saw your note in the chat. When we get in, and I'll just share for the recording that for many of these characteristics, we may be lacking the scientific data to come up with effective answers. And we just acknowledge that. And we are all going to have to work together to do what we can to give reasonable, accurate, and actionable answers when we get questions. This is the slide where we're going to talk about pooling, flooding, and adulteration. It's very similar to a slide that was in version 1.2. The things that we want to focus on this slide is that a lot can happen during the growing season. Not all of it's covered as part of an agricultural water assessment, so we can acknowledge those other situations here. But in particular, two regulatory things are the requirement to minimize risk caused by pooling water in the growing area, and the fact that produce contacted by natural floodwaters can be considered adulterated under FD&C with restrictions on how that contacted crop may be used. Generally speaking, flooded crops cannot be sold for use as food. There are three specific examples of exemptions to the agricultural water assessment. Each one of those is generally related to whether the grower knows the water is equivalent to drinking water quality from a microbiological standpoint, and also has the documentation to support the feeling that the water is equivalent to drinking water quality, and that the quality of the water will not change prior to use. This is the second big transition point. We went through concepts, then we went through the agricultural water systems inspection and assessment. Now we get back into the slides that cover testing. For veteran trainers, you will have covered this in previous versions, but now we may have a slightly different twist to it. In this slide, you're talking about testing as a valuable source of valuable information under any circumstances, under regulatory conditions. Only under specific circumstances is testing part of an agricultural water assessment. This slide helps participants understand what generic E. coli means in the context of the other indicators and fecal oral pathogens. Keep in mind that other scientifically valid indicators also can be used. When we get to this slide, we're talking about how to help a grower know when and where to collect a sample that's going to give them useful information. This information is useful in both Module 5.1 and 5.2 because any sample that's collected needs to be collected right. It has to use aseptic technique. The notes of this slide and some of the content of the slides helps a grower understand what is aseptic technique. In other words, clean containers, avoid contaminating or adding E. coli other than what was in the water to that bottle. The grower in the revised subparty is still given a lot of flexibility for how the analysis is done as long as the analyst is competent. Doesn't have to be a certified laboratory. The slide and the notes give practical recommendations about sample analysis, hold time, chilling the sample on the way to the lab. We also added the laboratories map that's hosted by NECAS Food Safety Resources Clearinghouse, which can be really useful for growers who are looking for a laboratory, especially if they're analyzing for generic E. coli. We're going into a series of optional slides that can be useful in a lot of situations. For each one of these, I just want to point out when you would choose to use this optional slide. If a grower opts to do testing of pre-harvest water, Using a method other than EPA method 1603, they're required to have documentation that that water is equivalent to method 1603. FDA put out a handy dandy fact sheet that states that these methods that are listed on the sheet are equivalent. And so that can be a useful part of documentation. Similarly, for presence absence methods, which are used in post harvest, keep in mind that this slide is not in Module 5.2, but presence absence tests for generic E. coli is required to be done for post harvest water. So this can be an important slide to show in Module 5.1 because it's going to be important to slide 5.2, and it doesn't appear in Module 5.2. Another optional slide, but a concept that's useful, is reviewing test results so that the grower can spot trends in water quality data early and address any issues that have changed before those issues cause produce safety risk. This is a graphic illustration, another optional slide of you've gone through and you've been sampling and you've been getting numbers that are in the low 50, less than 100, and then suddenly you get a large number. This is an opportunity to say something happened and I want to investigate what happened. So you can point that out to the growers using this slide. These are the two risk slides that I mentioned earlier. You're evaluating risk having to do with the water source, application method, and application timing, and discussing with the growers, how does that all tie together into risk? Now we're also including characteristics of the crop and environmental conditions into that thinking. This is the second example. The module ends with record keeping. It's important to the compliance and effective implementation in all the modules. In revised module 5.1, specific records that are required depend on what path the grower takes as they navigate the agricultural water systems inspection, the ag water assessment, and measures that are applied to manage the water quality and risk to produce. Records of the inspection and assessment are always required unless the grower is eligible for an exemption. Use this slide and the next one to share specific conditions when particular records are required. For instance, when a farm chooses to test the water as part of their assessment, they would consider or maybe need to have these records depending on the choices they make. Similarly, if a farm is exempt from an agricultural water assessment because they're using public water supply water, they would have to document that public water supply characteristics or testing with a certificate of compliance or some other way in order to support their eligibility for exemption. Farms that implement measures as one of the outcomes of their ag water assessment would also have a pick list of things that they are required to document depending on which measures they implement. When we summarize, it's useful to use that summary slide to reinforce concepts that were presented, help the participants realize how regulatory requirements can be used to effectively manage risk, protect produce safety, and manage conditions that affect water quality. In other words, enable people to make water use decisions in the context of the conditions that they identify in an agricultural water assessment. FDA has a web page. Again, there's the direct link to it in this QR code. And the fact sheets that were provided for the proposed ag water subpart E are now finalized and updated to reflect the final versions of that language.